let's talk about what is a limit. By reading this definition that we have here, it says that we have f of x, a function that is defined at all values in an open interval. So from this value of x to this value of x, all of the values included within that open interval, the function is defined in there. And that interval contains a, with the possible exception of a itself, right? So, and we're going to be L be a real number. If all values of the function f of x approach the real number L as the value of x's approach a number a, okay, approach, we don't want x to be equal to a. We want to see what's happening with the function when it is approaching that value of x equals a. Then we say that the limit of f of x as x approaches a is L. Okay, more succinct, as x gets closer and closer and closer to a, then f of x gets closer and stays close to a y equals L. How do we express this in symbols? We are going to use this in here. So that there, it's saying that the limit as x approaches a of a function f of x equals L. That L value is a y value, right? So a, it's a value in x. So we're going to find that value in the horizontal axis. L is a y value. So we're going to see that in the vertical axis. Let's define what do we mean by a one-side limit. So we have two one-side limits. We approach it, and we're talking about the way we are approaching that x value. Okay, remember that we are talking about x equals a. So if we talk about our number line, and I'm just going to make an example in here. So we have a number line, and we have x equals a right there. What we are trying to do is we are trying to approach x equals a from the left. You see this minus sign as an exponent for a. This means that we are approaching a from the left. So now remember, this is the left of a. This is the right of a, correct? So then when we are approaching a from the left, it means that you have to think about an arrow going towards the right. So you are approaching a from the left. It means that you're making the a values closer and closer and closer to a in this direction, all right? So that is approaching a from the left. When you're approaching a from the right, which is this one here, you have the plus sign now up here. It means that you now want to approach from this side. So you start here, and then you start moving closer and closer and closer to a, but from the right side. So here we are approaching a from the right. That is a language that you have to have very clear, all right? So we're moving to the left, but we are approaching from the right, all right? To and from, two different words. So we are approaching a from the right, but in order for us to do that, we need to start at a value that is on the right of a, and then move towards the left to be closer, or to get closer and closer and closer to that a. All right, so the definitions are in here. What does it mean to find the limit from the left? What does it mean to find the limit from the right? In words. Let's just go ahead and work with a problem. given a graph, and we want to evaluate a one-sided limit, all right? So here is our graph. This is a function f of x, which is defined by parts, meaning that we have something that looks like a polynomial in here, something that looks like a line in here, and then something that looks like a quadratic in here. So we are splitting the domain like in 3 different pieces. What is like, where do we have to pay attention in all this? So we have here, we need to find the limit as x approaches 0 from the left, all right? So we are approaching 0 from the left, and then we are approaching 0 from the right. So let's talk about what is this telling me. We are at x equals 0, all right? So x equals 0 is this line in here, right? So then now, because we want to find the one-side limit, we need to think about what is the value of the function as x approaches 0 from the left. So remember, approaching from the left means that you have to step at the left of 0. So I'm using -4, right? What I do in here is we need to find the y value that the function is approaching as the x values get closer and closer and closer to 0. So you're going to close this and get closer and closer and closer to 0. And the easier way to do this is just follow the function. You see the function moving towards x equals 0. And then when you get in here, what y value are we approaching? So think about what is the y value that your function is approaching as x approaches 0. So the y value, let me just erase this. And so the y value is going to be that -6 that you see in here, because you can see when x equals -2, y is -5. When x equals -1, then y is -6 point something. All right, and then as you make this x values smaller and smaller and smaller and smaller, you see how this -6 point something gets closer and closer and closer and closer to -6. So the limit when x is approaching 0 from the left for this function, it's going to be -6. All right, let's talk about the other side. So let's just forget about this and let's talk about what is the limit of the function as x approaches 0 from the right. All right, again, from the right means that we need to look now in that direction. So follow the function. So let's just start at 2, okay? Because that's the breaking point in here. So what happened with the function? When x equals 2, the function is not defined, right? It's defined up here. But the y values are getting closer to -3. And so what we do for here is we move here. And we see where is that function heading towards. So it's moving from -3 to -4 to -5 and to -6, and I'm looking at the y values. So again, if you think about what is happening with the y value as we get closer to 0 from the right, that is going to be -6 again. All right, something very important when we talk about limits. Limit is not asking you what is the value of the function at x equals 0, right? Limit is approaching. Where is the function heading towards as x approaches 0? What happens in this graph in particular? If you look at x equals 0, which is this x equals 0 that we have in here, right? So this is x equals 0. The function, when x equals 0, y is actually 4. So this point in here, it's where the function is defined. It's a closed circle. So this point in here is telling me that when x equals 0, f of 0 is actually 4, all right? That is the information given to me with this point. This is not the limit. We're not talking about the limit when we are evaluating the function, all right? If we want to know what is the value of function when x equals 0, we plug it in, we find who is f of 0. Oh, that's 4. That is the value of the function when x equals 0. That has nothing to do with the limit, all right? The limit is just the value the function is approaching, not the value where the function is defined, all right? So it doesn't matter that when x equals 0, when x equals 0, y is not -6. The limit is -6, so the function is approaching -6 as we approach 0, but that is not the value of the function, okay? And that is okay. So hope that is clear. Let's go to example number 2, and here we're going to do the same. We're going to evaluate that one-side limit, and now we need to find the limit when x is approaching 0 from the right and from the left. So then again, we start at x equals 0, and so x equals 0 is this line in here, so that is where we are at. What do we want to look? So when x approaches 0 from the left, and when x is approaching 0 from the right. All right, so let's start with the left. So remember, this is the value that you are approaching. So for that, you look at the function and you see what value is the function approaching when x is approaching 0 from the left. All right, again, from the left is this trajectory. So just follow the function, and I started very, very far away, but I'm just trying to show you what does it mean to approach the function from the left. So again, from the negative infinity, you are approaching 0. The function, so you actually care about what is happening very, very close to 0. All right, so this is the neighborhood that you really, really care about. So what is happening with that function as x approaches 0? So again, let's do this. So we want to get, and it's going to be a little blurry, but that's fine. All right, so again, we want to get closer to 0. So remember that what you are actually doing is getting values here in the x-axis that are very close to 0 in this direction because we are approaching it from the left. And so when you look at that, you have to look at this piece of the function and see what is happening with the y values as you approach 0. So with this point in here, the y value is this one. And then as we move to the left, the values are getting closer and closer to who? To 4. So then the limit as x approaches 0 from the left is going to be 4. All right. And then we do the same, but from the right. Let's see if the internet decides to show my graph. All right, from the right, it's going to be pretty much the same, but now we are working with this little piece in here. There we go. Okay, and so we work with this little piece in here. Again, you are choosing values that are getting closer and closer and closer to 0, but from the other direction. And then when you do that, you have to look at, and I'm going to remove this from here so I have some space. You're looking at this little piece in here. You will look at what is happening with the y values. And again, the y values are getting close to 4. Again, is this telling you that the function evaluated the function evaluated at 0 is 4? No, that is not what the limit is telling you, all right? The limit is just telling you that the function is approaching 4 as x approaches 0, but not necessarily that the value of the function for x equals 0 is 4. Actually, the value for the function when x equals 0, it's -2, okay? -2 and 4 are not the same. That's totally fine, all right? The limit of the function is not telling you the value of the function. It's just telling you a value that the function is actually approaching, all right? Okay, and so example number 3, now we are talking about x equals 4, all right? So again, where is x equals 4? This in here. So that is your x equals 4. So we are talking about what's happening when we approach 4 from the left, all right? So again, if you look at that line that I'm making in there, the left of the function is this in here, right? So then we are going to approach 4 from the left, so meaning that we are starting at -infinity, and we get close to 4. So if you look at the function where we are close to 4, what is the y value that we are approaching? We are approaching 3. And that is going to be our limit. All right. On the other side, again, this is x equals 4. We want to approach that from the right. So it means that we start at +infinity and we approach 4. The only piece of function that we have in this direction is this one. So this is the one that we're going to use. So again, very close to it. What happens as I approach 4 from the right, the y value, it's approaching -3. So then this in here, it's going to be a -3, right? Is there an issue with the limit not being the same? No, the limits from the right and from the left are going, can be different. Again, that doesn't mean that the problem is incorrect. What this means is that the limit doesn't exist, and we're going to talk about that when we talk about evaluating two-sided limits from a graph in another video.